So this is going along with number 4 on your page where we have some other examples. And again, we are going to sum up the valence electrons so that we know how many electrons that we can have. We're going to take the stable number minus the number of valence electrons to figure out how many bonds each atom makes. And so hydrogen is 2 minus 1. So hydrogen makes 1 bond, means it puts 1 electron in. Fluorine is 8 minus 7, which means that fluorine puts 1 electron in as well. We had 8. We've used 2. We have 6 more. Hydrogen's stable number is 2, so hydrogen never gets lone pairs. Those 6 electrons are going to go around the fluorine atom. Now, once again, you can either use an arrow to point to the negative side because this does indeed have a dipole moment, or if we redraw it and we want to use the deltas, we're going to use delta negative on the side with the higher electronegativity and delta positive on the side with the lower electronegativity. Again, this is linear, it's in a line, and it does have a dipole moment. We show the dipole moment either by the arrow pointing to the negative side or by the delta plus and the delta minus. N2, again, we sum the valence electrons, which means we have 10 electrons to work with. Stable number minus valence electrons means that a nitrogen atom, when bonding in a typical fashion, would need to make 3 bonds. That means that each nitrogen puts 3 electrons into the bond. That's 6 of our 10 electrons. The other 4 get distributed evenly. We would write no dipole moment because it is symmetrical, nonpolar, does not need a positive side or a negative side. This is linear, 180-degree bond angle. NH3, again, we sum up the valence electrons. Nitrogen, as we said, makes 3 bonds. Hydrogen, as we said, makes 1 bond. Our nitrogen has to make 3 bonds with 3 different atoms. So the nitrogen puts 3 electrons into bonds. Each hydrogen brings an electron to bond. That's 6 electrons. The other 2 give nitrogen a lone pair hat. Once again, you can either point to the negative side, nitrogen has a higher electronegativity, or you can do your delta plus and delta minus. The lines or the dots can go with either one, but again, the delta minus is going to go with the higher electronegativity. The delta plus is going to go with the lower electronegativity. Because nitrogen has 1, 2, 3 atoms bonded and 1 lone pair, we're going to say that this is trigonal, pyramidal, or trigonal pyramid, 109.5 degree bond angle. We know it's actually a little less than that, but that's okay. And again, it does have a dipole moment. Last one on this page for us, last one in number 4, NO positive. Again, we add up valence electrons. Positive charge means take 1 away, means that we have 10 electrons to work with. I have 2 atoms with 10 electrons. Looks to me like they're going to bond the same way that nitrogen N2 did. 6 in the middle, 2 on top for each. And again, we would put it in brackets and put the charge on the outside. Since oxygen has a higher electronegativity, we would probably use the arrow for this one so as not to get confused with the delta plus and the delta minus. and the positive charge on the molecule. Don't forget that we can also make those 3 lines, I'm sorry, those 6 dots, 3 lines. Because this is an overall charged species, it does need to go in brackets with the charge outside. We can still use the arrow method even with lines or dots. So I'm going to stop there. Again, that was number 4 if anybody needed help going back over those.